Hello everyone, in this video I'm gonna discuss about the next questions of our pure mathematics P1 paper, which is 2025 May. So in the previous video I have already discussed the first 4 questions. Now in this video I'm gonna discuss the questions from 5 and onwards. So here the question is, the line L1 has an equation x minus 2y plus 25 is equal to 0. There is another line L2 which is passing through the origin and it is perpendicular to L1. Now when the equations are passing through origin, their equations are always given like y is equal to mx. This is an important point. So here the equation will be for the line L2, it will be y equal to mx, where m is the gradient of this line. They said the line L2 is perpendicular to line L1. So what does it mean? That the gradient of both the lines, there will be negative reciprocal of each other. So for this line, if you need to find out the gradient, the line should be in a form y is equal to mx plus c. So I make this line in that form. So 2y is equal to x plus 25, and then y is equal to a half of x plus 25 over 2. So from here the line L1 has a gradient of a half. So the gradient of line L2, it will be negative reciprocal of a half, which is negative 2. So now we have to find the equation of line L2. So that is y is equal to mx. So that is negative 2x. Y is equal to negative 2x. That is the equation of line. So we have found this part here, that is the A part. Then they said the line L1 and L2, they intersect at P. Use algebra to find the coordinates of P. So we have one equation, let's say this is equation 1, and the another equation, this one y equal to negative 2x, is the equation 2. So if they are intersecting, there will be common points. So let's compare their y coordinates. Or what I can do, I can take the value of y from this equation 2 and I can substitute it in the equation 1. So from here what I'm gonna do, this is for the B part to find the coordinates. So it will be x minus 2 times of negative 2x plus 25, and that is equal to 0. So we get x plus 2 times 2x, which is 4x, plus 25 is equal to 0, which gives me 5x plus 25 is equal to 0, and upon solving it, 5x is equal to negative 25, which gives x is equal to negative 5. Now because we have to find the coordinates of P, that means I need to find the y value also. So you can substitute this y value in either equation 2 or 1, you will get the same coordinates. So y is equal to negative 2 times negative 5, and that is 10. So the coordinates of P are negative 5, 10. Then they said, hence find the shortest distance from L1 to the origin. Now this is a very important part. We have to find the shortest distance. Now what is the meaning of shortest distance over here? We have the situation like this. There is a line and the both lines are passing through negative 5, 10, and the line L2 is passing through origin also. So this is origin, and negative 5, 10, let's say that point is somewhere here. So this line will be something like this. This is line L2. Now line L1 and L2 are perpendicular, and that line is also passing through here. So if it is perpendicular, so it should be something like this. And if it is like this, so these angles are 90 degree. And if you have to find out the distance, the shortest distance of this line L1 from this point, so now the distances, if you have to find out, there are multiple cases. You can find the distance from this point here also, here also, here also, and so on. But they are asking for the shortest distance, and shortest distance is this one. So how we can find out this shortest distance? Now that we have to work on. So for that, what I'm gonna do, I will be redrawing this equation. So this is the situation. One line is passing like this way, and another line is passing this way, and we have to find out this distance. Let's say this is O and this is point P is given. So we have to find out OP. How we can find out this OP? This is given as the full line as negative 5, 10 point. So if you see here, if I find out this distance, this distance is gonna be 10 and this distance is gonna be -5, and we have to find out OP. So I can apply the Pythagoras theorem. OP square is equal to -5 squared plus this distance is 10, so that is 10 square. So from here I am getting it like 100 plus 25, which is 125, and if I need to find out now OP only, so that will be square root of 125 units, which is 5 root 5 units. That is the answer for the third part. They said you have to write it as a simplified, fully simplified search, so this is the answer. Now we go to the next question, and in the next question let's see what is given here. Yes, this question is given like a triangle, and I can see a part of the circle. The shaded area shows a plain view of the helicopter landing pad. The area consists of major sector of AOB. Major sector means they are talking about this angle and then this segment. And then O is the center and it is joined with a triangle AOC, and few dimensions are also given. So we have given AO, that is the radius, and that is equal to OB also 15 meters. Then we have given BC. BC is given this part, that small part, that is from B to C, and that part is 2 meters. So we can say that OC will be equal to OB plus BC, that is 15 plus 2, which is 17 meters. Then CBO is a straight line. CBO is a straight line, and angle ACO, this angle is given as 0.6 radians. Show that angle COA is 1.847 radians to the 3 decimal places. Now how to do this question? In order to find this angle COA, so that means this angle, I have to find it out. To find this angle, what I can do, see, we can apply the sine rule here, but for sine rule, if I have to find this angle, I need to know this angle as well. So now what I can do here, I have no idea what is this angle, but if you see, I know this angle, I can find out this angle. In that case, once you know this angle and you already know this angle, so we can find this third angle. And why we are using this angle? Because the opposite side is 17 is given to us, 17 meters, and here opposite to angle C, this side is given as 15 meters. So I will be using that part. So I will apply the sine rule in this triangle here now, and what I'm gonna say, that sine of angle OAC divided by 17 is equal to sine of angle C divided by this side 15. So we need to find out sine of angle OAC, and that is equal to 17 over 15 times sine of this angle ACO, which is given as 0.6. And when you will simplify this and you have to find angle OAC, it will be sine inverse of this whole value, which is 17 over 15 times sine of 0.6, and this is going to be 0.6944 dot dot dot. Now we have to find out angle COA, that is equal to the sum of all the angles 180 degree minus the angle 0.6 and minus this 0.6944, and that will give you the answer 1.847 radians. Hence we prove the first part of this question. So I can say the angle is, this angle is 1.847, and using this angle I can find out this angle also. So this is the first part of this question. Now we talk about the second part of the question, and that is the total area of the helicopter landing pad. So that means we need to find the area of triangle. So this is based on area, the B part, area of the triangle AOC plus the area of the major sector, area of major sector. Now this is very important here, that when you have to find the area of major sector, you need to find this angle. And how we can find out this angle? 2 pi take away 1.847. This is the important thing here. So when you find the area of triangle, that will be half of these two sides, because I know them. So it is half of 15 times 17 times sine of angle O, and that is 1.847, plus we have to find the area of this whole sector, that is half of r square, which is 15 square theta. And this theta is basically this angle, because it is, this angle is 1.847 and we need to find the major area, so it is this. So it will be 2 pi minus 1.847, and then you have to keep it in bracket. When you will solve this part, you will be getting 621.738, which is, because we have to give the answer to three significant figures, so it will be 622 meter square. Then we have the next part. You need to find out the perimeter of this helicopter landing pad. When you have to find the perimeter, so it is very important to understand that we need this length, we need this length, and then we need the arc length. So basically I need the perimeter, so it will be AC plus BC plus the arc length, which is r theta. So r theta is going to be here 15 times, again we have to find out the same way. So it is 15 multiplied by 2 pi minus 1.847, and that is going to be 66.542 meters. Then BC length is already known too. The only thing important is we need to find out now this AC. So for that I can use the cosine rule, and cosine rule says cos of angle O is equal to this side square, which is 17 square, plus 15 square, that is this side, and minus AC square divided by 2 times 17 times 15. Angle O we already know it is 1.847. So when you will simplify this whole thing, you will be getting your AC as 25.555 meters, like that. So now you have to add the values. What are those values? AC, this value, plus you will have to add this value, which is r theta, and plus this value 2 meters. And when you will add AC plus this arc length BC, it is shown like this, BA sorry, and plus BC, this is going to be 94.0977, like that. So it is 94.1 meters. That completes this question. So this is all for our today's lesson. Thank you.